0.60 gram sample of potassium iodate was dissolved in water and excess potassium iodide was added to it. The minimum amount of 3 moles per cubic decimeter HCl required to completely convert potassium iodate to triiodide ions is. At the very beginning, 0.60 grams of solid potassium iodate was dissolved in water to prepare aqueous potassium iodate solution. Potassium iodate is an ionic compound. Therefore, in aqueous solution, potassium iodate completely dissociates into aqueous potassium ions and aqueous iodate ions. Then, excess aqueous potassium iodide and 3 moles per cubic decimeter HCl were added to the aqueous potassium iodate solution. Addition of this HCl makes this solution acidic. Now we will find out the reaction between potassium iodate and potassium iodide in the presence of acidic medium. In the presence of acidic medium, these iodate ions react with iodide ions. This reaction is a redox reaction. These iodate ions reduce to iodine. These iodide ions oxidize to iodine. In the presence of excess potassium iodide, all the iodate ions oxidize to iodine. Therefore, this final mixture contains the produced iodine and the remaining iodide ions. These iodide ions together with iodine molecules forms triiodide ions. Therefore, in the presence of these excess iodide ions, all these iodine molecules converts to triiodide ions. Now we will balance this redox reaction. During this redox reaction, iodate ions reduce to iodine as well as iodide ions also oxidize to iodine. When balancing redox reactions using this method, it is easy for us to write iodine as two different products. Otherwise, it will be difficult for you to balance the redox reaction using this method. These are the iodine molecules produced by the oxidation of iodide ions, and these are the iodine molecules produced by the reduction of iodate ions. Oxidation state of iodine in iodide ion is -1 and oxidation state of iodine atoms in iodine molecule is 0. This iodine molecule has 2 iodine atoms. Therefore, we need to balance the number of iodine atoms. This is the structure of I2 molecule. It contains 2 iodine atoms and the oxidation state of each iodine atom is 0. We need 2 iodide ions to produce 1 iodine molecule. That is why we need to use the coefficient number 2. Now we need to find the number of electrons involved in this process. Oxidation state of this iodide ion is -1. When this -1 oxidation state converts to 0 oxidation state, 1 electron has been removed. But 2 iodide ions are involved in the production of 1 iodine molecule. Therefore, the total number of electrons released during the process is 2 electrons. 1 electron has been released per 1 iodine atom. Therefore, the total number of electrons involved in this oxidation process is 2 electrons. Oxidation state of this iodine is +5 and the oxidation state of each iodine atoms in iodine molecule is 0. The next step is to find the number of electrons involved in this reduction process. We need to balance the number of iodine atoms. I2 molecule contains 2 iodine atoms. Therefore, we need to use the coefficient 2 in front of iodate ion. 2 iodate molecules required to produce 1 iodine molecule. The difference between +5 and 0 is 5 electrons. Therefore, 5 electrons have been accepted per 1 iodine atom. Therefore, 10 electrons are involved in the overall reduction process. We will check the number of electrons involved in this oxidation and reduction process once again. The difference between -1 and 0 is 1 electron, but there are 2 atoms involved. Therefore, 1 electron is per 1 atom. Therefore, the total number of electrons involved in the oxidation process is 2 electrons. The difference between +5 and 0 is 5 electrons. That 5 electrons are per 1 iodine atom. But 2 iodine atoms involved during the reduction process. Therefore, the total number of electrons involved in the reduction process is 10 electrons. The next step is to balance the number of electrons. 2 electrons are involved in the oxidation process and 10 electrons are involved in the reduction process. Therefore, we need to balance the number of electrons. Therefore, we will multiply 2 electrons by 5. At the same time, you need to multiply these two coefficients by 5 as well. 5 times 2 is 10. Next, we will balance the number of oxygen atoms. There are 6 oxygen atoms on the left and there are no oxygen atoms on the right. Therefore, add 6 water molecules to the right. Finally, balance the number of hydrogen atoms. There are 12 hydrogen atoms on the right and there are no hydrogen atoms on the left. Therefore, add 12 H plus ions to the left. These iodine molecules together is 6I2. This is the balanced ionic equation for the reaction between iodate ions and iodide ions in the presence of acidic medium. These are not the simplest molar ratio between the reactants and the products. Therefore, divide the whole equation by 2 to get the final balanced ionic equation. This is the balanced ionic equation for the reaction between iodate ions and iodide ions in acidic medium. Now we will balance the same redox reaction using half equation method. Oxidation process is oxidation of iodide ions into iodine molecules. First balance the number of iodine atoms, then balance the number of electrons. The oxidation state of iodide is -1 and the oxidation state of iodine is 0. -1 to 0, it involves 1 electron, but there are 2 atoms involved. Therefore, 2 electrons have been released during the oxidation process. The reduction process is reduction of iodate ions into iodine molecules. First, balance the number of iodine atoms. The oxidation state of iodine in iodate ion is +5 and the oxidation state of iodine in iodine molecule is 0. +5 to 0 involves 5 electrons. But there are 2 iodine atoms involved in the reduction process. Therefore, the total number of electrons accepted during the reduction process is 10 electrons. Now we will balance the number of oxygen atoms. There are 6 oxygen atoms on the left. Therefore, add 6 water molecules to the right. Finally, balance the number of hydrogen atoms. There are 12 hydrogen atoms on the right. Therefore, add 12 H plus ions to the left. 2 electrons have been released during the oxidation process and 10 electrons have been accepted during the reduction process. Therefore, the next step is to balance the number of electrons. Therefore, to balance the number of electrons, multiply this whole oxidation equation by 5. Finally, add these two reactions together to get the final balanced ionic equation. These coefficients are not the simplest molar ratios between the reactants and the products. Therefore, divide the whole equation by 2. This is a balanced ionic equation for the reaction between iodate ions and iodide ions in the presence of acidic medium. These are the balanced ionic equations involved in these reactions. We need to calculate the minimum amount of 3 moles per cubic decimeter HCl required to completely convert potassium iodate to triiodide ions. In other words, we need to calculate the minimum volume of 3 moles per cubic decimeter HCl required to completely convert these iodate ions into triiodide ions. The mass of potassium iodate have been given. Therefore, we can calculate the number of moles of iodate ions present in this sample. In the presence of excess iodide ions, all of these iodate ions reduce to iodine. In the presence of excess Ki, the produced iodine together with these iodide ions forms triiodide ions. Therefore, students, no need to worry about calculating the number of moles of these iodides or triiodide ions. The reason is all of these iodate ions finally converts to triiodide ions. Therefore, calculate the number of moles of iodate ions and using stoichiometry, calculate the required number of moles of H plus ions. The concentration of the acid was given. Therefore, we can calculate the required volume of HCl. First, we will calculate the number of moles of potassium iodate. The mass of potassium iodate was given and using these atomic masses, we can calculate the molar mass of potassium iodate. Number of moles of KiO3 equals Mass 0.60 grams divided by the molar mass is 214 grams per mole. As this is not the final answer, we can keep this fraction. Therefore, this is the number of moles of KiO3. This is the dissociation of KiO3. Therefore, number of moles of KiO3 is the same as the number of moles of iodate ions. Therefore, the number of moles of iodate ions equals 0.60 divided by 214 moles. If the number of moles of iodate ions is X, the number of moles of H plus ions is 6X. The reason is the stoichiometry between iodate and H plus is 1 to 6. Therefore, the number of moles of H plus ions required is 6 times of the number of moles of iodate ions. Therefore, the required number of moles of H plus is 0.60 divided by 214 times 6 moles. This is the dissociation of HCl. Therefore, the number of moles of H plus ions is the same as the number of moles of HCl. Concentration is number of moles divided by volume. Therefore, volume equals number of moles divided by the concentration. Therefore, the required volume of HCl equals number of moles of HCl, this value, divided by the concentration of HCl, that is 3 moles per cubic decimeter. Therefore, the volume of HCl equals the number of moles of HCl 0.60 times 6 divided by 214 divided by the concentration of HCl, that is 3 moles per cubic decimeter. The answer is 5.6 times 10 to the negative third cubic decimeters. But the answers are given in cubic centimeters. Therefore, we need to convert this volume into cubic centimeters. To convert cubic decimeters into cubic centimeters, we need to multiply this answer by 1000. 5.6 times 10 to the negative third multiplied by 1000 equals 5.6 cubic centimeters. The answer is number 3.